Welcome to my YouTube channel. Today I will discuss continuity of multivariable function. In the previous lecture, I have discussed double limit and repeated limits. A function f of xy is continuous at the point x0, y0 if first f of xy is defined at x0, y0. Second, the limits as xy approaches to x0, y0, f of xy exists. And the third one is limit of this as x tends to x0, y0, f of xy is equal to f of x0, y0. So if this three condition holds, then a function f of xy is said to be continuous at the point x0, y0. Contrapositively, if one of these three does not hold, then we can say that this function is not continuous at this point. So generally, we to show the continuity of a function, first we check the limit of the function, that is double limit, is it exist or not. If it is exist, we see is it equal to f of x0, y0 or not. Otherwise, if it does not exist, then we can say this function is not continuous. So this function from x cross y to r. So we said that this function is continuous at x0, y0, that is contains in the domain, that is x cross y, like this. If this is x and this is y, then any point from here we take a particular point. We define the continuity of a function at a particular point. So function f of xy is continuous if it is continuous at every point of its domain. So if at every point of the domain for this function, the function is continuous, then we say that this function is continuous. Not in the point, in this domain, this function will be continuous. So let us check the continuity of some function. First, let us take example 1, that is f of xy equal to x minus y whole square divided by x square plus y square when x comma y not equal to 0, and 0 when not equal to 0 comma 0, and this happens when x comma y equal to 0 0. So this function defined as this when xy not equal to 0 0 and 0 when equal to 0. So to show the continuity of this function at 0 0, we have to show that the limit as xy tends to 0 0 of this function should be equal to 0. So first we find the limit of this function. Let us take the path y equal to mx. So as xy approaches to 0 0 through this line, so this is the line y equal to mx, this theta will be m equal to tan theta. Then now we put here and we find that limit xy goes to 0 0 becomes x tends to 0, and x minus y, that is mx whole square divided by x square plus y means m square into x square. So this becomes limit x tends to 0, and as this x square into 1 minus m whole square divided by x square into 1 plus m square, x square cancel out, then this becomes 1 minus m whole square divided by 1 plus m square. So this depends on m. For different values of m, this limit be different. So this limit of this function does not exist at 0 0. So from this we can conclude that this function is not continuous. Let us take another example. X to the power 4, this is x to the power 4 plus y square when xy not equal to 0 0 and 0 when xy equal to 0, 0. So for this, to show the continuity of this function, we have to find or we have to check that limit exists or not. So first of all, if we take y equal to 0 path, then this limit goes, this becomes 0 and this is x to the power 4 divided by x to the power 4, and then it goes to 1. And if we take the path y equal to x square, then we get from this, that is limit x tends to 0, x to the power 4 divided by x to the power 4 into y square, that is this will be x to the power 4. So from this we get 2x to the power 4 and over x to the power 4, so we get half. So for two different paths we get two different values. So from this we can say this limit does not exist, and so this f of xy is not continuous at x0 y0, that is 0, 0. You can note. Now we check the continuity of function. So first take f of x y equal to 2x into x square minus y square divided by x square plus y square when x comma y not equal to 0, 0 and 0 when xy equal to 0, 0. So we have to show this function is continuous. So for continuity, we have to find limit xy tends to 0, 0, 2x x square minus y square divided by x square plus y square. This should be f of 0, 0, that is at 0, 0 becomes 0. So we have to find that limit this equal to 0. So now we prove this by epsilon delta definition of limit. What is the definition? So first we take epsilon greater than 0, and if there exists a corresponding delta greater than 0 such that this f of xy minus this value, that is 0, modulus of this value less than epsilon whenever 0 less than x minus x0, that is 0, and 0 less than modulus less than delta. We have to show that limit of this function equal to 0, and we prove this by epsilon delta neighborhood. So let us show. So you can note, first let us take epsilon greater than 0 be given, and then we find this minus 0, that is can be written as 2x cube divided by x square plus y square minus 2xy square divided by x square plus y square modulus, and this can be written as less or equal to 2x cube divided by x square plus y square modulus value, and this become plus 2x y square divided by x square plus y square. So from this we can write 2 into modulus x, and this becomes x square plus y square, and this becomes 2 into modulus x, and this becomes y square divided by x square plus y square. As we get x square by x square plus y square less or equal to x square plus y square divided by x square plus y square, that is less or equal to 1. So we can put 1 here, and then we get less or equal to 2 modulus x, 2 modulus x, that is 4 modulus x, and as this is condition 0 modulus x less than delta, 0 less than y less than delta, we can put here 4 into delta. So if we choose delta less or equal to epsilon by 4, then from this we get this is epsilon. So for epsilon greater than 0, if we choose delta less or equal to epsilon by 4, then we get modulus of this function minus 0 less than epsilon. So we get from the epsilon delta definition that limit of this function equal to 0. So from this we can write, you can note, from this we can write limit xy tends to 0, 0, this function equal to f of 0, 0 equal to 0. So from this function divided by x square plus y square is this function is continuous. This eta when x equal to xy not equal to 0, 0 and 0 when xy equal to 0 0, this function is continuous at 0 0. One last example, that is f of xy equal to y sine 1 by x when x not equal to 0 and 0 when x equal to 0. So we have to show that this is continuous. So we have to show that this is continuous. So to show continuity, we have to show that limit xy tends to 0 0, y sine 1 by x equal to f of 0 0, that is 0. So you have to show this, and if we can show this, we can say that this function is continuous. And for this we use epsilon delta definition. So first let epsilon greater than 0 be given, and then we find 1 y sine 1 by x minus 0 lesser equal to modulus y modulus sine 1 by x, and as this is as sine theta belongs to -1 to 1, so we can put maximum value here. So this becomes modulus y into 1, and if we choose, and this is less than delta, as we get this condition, so we can put here this is delta, and if we choose delta lesser equal to epsilon, then we can write this is lesser equal to epsilon. So whenever delta epsilon greater than 0 be given, we can find delta which is lesser equal to epsilon. For that, this less than epsilon whenever these two happen, that is 0 less than this, 0 less than modulus y less than delta. So we prove that limit of this function is equal to 0, and 0 is nothing but f of 0 0, it is 0. So from this we can say this function is continuous at 0 0. There is an interesting thing about this example. I have discussed double limit and iterated limit. That is double limit, and if it's equal to L, then this implies iterated limits equal, and it should be also L. Converse may not happen, but contrapositively we can say if iterated limits not equal, then the double limit does not exist. So in this case, iterated limit does not exist, but the double limit exists. How? If we find limit x tends to 0 and limit y tends to 0, y sine 1 by x, and from this limit x tends to 0, so if we put y tends to 0 here, so this becomes 0 into sine 1 by x, so 0 be, so this will be 0. But if we find this limit as first y goes to 0 and then x goes to 0, so y sine 1 by x. So as 1 by x does not exist at x tends to 0, so this does not exist, and therefore this limit does not exist. But we have proved that the double limit for this function is exist and equal to 0. Why this happen? This happen because of the definition. In the definition of repeated limit, or in the result, we discuss that if double limit exists and equal to L, then the iterated limit this and this exist and be equal if and only these two limits, limit x tends to 0 the function and limit y tends to 0, this function should be exist. So in this case, one of this limit does not exist, that is limit x tends to 0, this does not exist, so therefore this limit does not exist, and therefore the repeated limit does not exist, but the double limit exists. For today, that's it. We have discussed continuity of multivariable function and check the continuity and discontinuity, and we take I think 4 examples, and each of these examples is very important for your course. So if you like it, please do subscribe the channel and share with your friends. Thank you very much. Dhanawad.